Good afternoon. We will now continue with section 2.2 on quadratic forms. We introduced quadratic forms last time, and they are going to be used and are important in the classification of critical points. So we're looking at section 2.2 of the notes. And in this lecture, this video recording, we're going to look at classification of critical points in two or more dimensions. Boom. The signature of quadratic forms can help to determine the behavior of a function around a critical point. Critical point x0, which we found. I suppose I need a u here, but so be it. And in doing so, we used Taylor expansions. So fx0 factor expanded around dx factor is f at x0 itself plus 0, because the gradient of f at x0 is 0. Those are the first order conditions, plus the second order terms h. We take dx as column factor and dxt is a row factor, plus order delta x to the power 3. So if matrix A of q of x is a Hessian, H is f xi xj, so this is the partial derivative of f with respect to xi xj being components, so ij is 1, 2, 3 or n, then q is bigger than 0. Positive definites will give a local minimum, yes, q less than 0. Negative definite gives us a local maximum. Q is indefinite, neither a maximum or a minimum, with that determinant of A unequal to 0. Unequal to 0. In case n is 2, we then have a saddle point but for n bigger or equal than 3, the indefinite case, it can be more complicated. In the case of a positive semi-definiteness, so Q bigger or equal than 0, we could be at a minimum, but it may be that it isn't, that is a minimum. Similar reasoning for negative semi-definiteness with Q less or equal than 0. So that doesn't necessarily give us a maximum. In such cases, so PSD or NSD, we need further analysis to determine the behavior, to classify the critical points. Positive definiteness and negative definiteness. The PD and ND are sufficient conditions to determine whether it's a maximum or minimum. PSD and NSD are necessary but not sufficient conditions for maximum or minimum, so we need to do more analysis. In cases where we cannot decide, we should say it's indefinite. A bit vague, but basically these are the rest cases. But these ones, positive definiteness and negative definiteness, are the most pressing. So let's look at a series of examples. Here are the questions. One, Q of x1, x2 is 4x1 squared plus 3x2 squared. Well, Q bigger than 0 except when x is 0. So this is positive definite. Now go back to the definition except when x1 is x2 is 0. 2, well, we continue, minus x1 squared minus 2x2 squared, so you can analyze that just using the definition because the situation is complex. Q is x1 squared minus x2 squared, so now we can look at whether there is a case, whether there is an x1 x2 for which is negative and whether there is an x1 x2 for which is positive. That would make it indefinite. Oh, I'm using the wrong denotation. There's 2, 3, 4. Qx1 comma x2 is x1 squared, and 5, qx1 is minus x2 squared. So what is the classification in these four last cases? So that's for the those are questions. For NS2 we can actually analyze it in detail, so that's useful. Let us let's analyze the NS2 case in full generality. By taking general description of a quadratic into the ax1 squared plus 2b(1x2) plus cx2 squared, which is for a unequal to 0. The case for a is 0 we deal with later. This is a x1 plus b over a, kind of using the ABC formula, squared plus c minus b squared over a x2 squared. And now if we take out a entirely, we have x1 plus b a x2 squared plus ac minus b squared x2 over a squared. Closure. So we divided here by a and then multiply this one by a, and then we put this one put it in front, so we pick up another a which is here, which is why we have an a squared there. This is written as the sum of two squares. So now a and a times ac minus b squared, which is the determinant of a matrix, determine what cases we have. So recall that a multiplies the first quadratic, a times ac minus b squared, the second square. Check that this is true. So now we can distinguish, the cases. Recall a is unequal to 0 as follows: q is bigger than 0 if a is bigger than 0, and if a is bigger than 0, then ac minus b squared needs to be bigger than 0 for the second square to have positive coefficients. Q less than 0 if a less than 0, that gives the coefficient in the first square is negative, and for the second one to be negative, a times ac minus b squared needs to be negative. So since a is negative, this needs to be positive. Q bigger or equal than 0, so that's P as D. AC minus b squared is 0, so one of the and a can't be 0, so a is bigger than 0. This implies, since a is bigger than 0, that c needs to be bigger than 0. Q less or equal than 0, so NSD, if AC minus B squared is 0 and A less than 0. So if the first square is, that implies that c is less than 0. If a is less than, because ac minus b squared needs to be 0 and b squared is positive. Otherwise, so in the other cases, q is indefinite. So that what remains is case ac minus b squared is less than 0, because the other cases we have captured. If a is 0, this is left in an exercise, then we can do a similar analysis interchanging the role of a and c, assuming c is not equal to 0. In fact, a is 0 gives us q x1 x2 is 2b x1 x2 plus c x2 squared. Now we're assuming that c is unequal to 0, so this is c x2 plus b over c x1 squared minus b squared c over x1 squared is c x2 plus b over c x1 squared minus b x1 over c squared. So again, and now you can continue there. Now it's only determined by the sign. So now you can analyze this case further by looking at the signs of the two squares. If both a is c is 0, then q x1 x2 is 2b x1 x2, which is indefinite. So exercise, another exercise. So this you need to continue. This is an exercise. Continue what cases you get for this case, and the next exercise is check the above analysis for the examples 1 to 5 on the previous page. So in other words, identify the A, B, and C for each of those 5 examples, and on the previous page, check the above rules for the examples 1 to 5 on the previous page. What is also clear is that the determinant what do you do now? Oops. Is that the determinant that A plays an important role, where A is A, B, C, D, given that the quadratic for n is 2 can be written as xta is xta x So next time we consider the case n is 3 and an example. Thank you very much.